Good morning, respected teacher and dear all my friends. Thank you so much for the teacher giving me opportunity to the presentation on the topic of understanding reflective, symmetric and transitive in relation with examples and graphical representation. Outlines here mentioned here: introduction to relation, reflective relation, graphical represents of reflective relation, symmetric relation, graphical represent of symmetric relation, transitive relation, graphical represent of transitive relation, importance of relation, application of reflective, symmetric and transitive, and conclusion. These are the outlines. Outlines. Then first slide is introduction to relation. Relation. A relation from a set A into a set B is a subset of Cartesian product A cross B and is denoted by R. Then first element of all order pair AB belongs to R is called domain of R, and second element of all order pair AB belongs to R is called image or range of R. There are the properties of relation. One is reflective, another is symmetric, another is transitive. Next slide is reflective relation. Reflective relation means a relation R on a set A is reflective if A R A for every A belongs to A. That is, if AA belongs to R for every A belongs to A. This simply that each element of A is related to itself. For example, if R1 equal to 1 1 2 2 3 3 1 3 be a relation on A, then A equal to 1 2 3, then R1 is a reflective relation because there is every A belongs to A belongs to R1. That means there is a set 1 2 3, 1 1 also there is a relation, and 2 2 also there is a relation, and 3 3 also there is a relation. That's why it is a reflective relation. Another R2. Same relation A, we can make the relation R2 1 1 1 2 2 3 3 3. Then R2 is not a reflective relation because since for every 2 belongs to A but 2 2 does not belongs to R2. That's why it is not a reflective relation. Next slide. Then graphical represent of reflective relation. A relation is reflective if and only if there is a loop in every vertex of a diagonal graph so that order pair of form AA occurs in a relation. Suppose R1 equal to 1 1 2 2 3 3 1 2 be a relation on A equal to 1 2 3, then R1 is a reflective relation since every A belongs to A, AA belongs to R1. In this graphical representation, there is a 1, vertex 1, there is a loop, and another vertex 2, there is also loop. Then another vertex 3, there is also loop. That means every vertex has in a loop, and another also 1, vertex 1 goes to vertex 2. That's why it is a reflective relation. Next slide. Next slide is the symmetric relation. Symmetric relation means a relation R on a set A is a symmetric if whenever A belongs to B, AB belongs to R, then BA belongs to R. That is, if ARB implies BRA, this means any one element is related to any other element, then the second element is related to first. It is a symmetric relation. For example, R1 equal to 1 1 1 2 1 3 2 2 2 1 3 1, and on A set 1 2 3 is a symmetric relation. Another, R2 equal to xy belongs to R, x square plus y square equal to 1 is a symmetric relation on R. Since if x square plus y square equal to 1, then y square plus x square equal to 1. These both are same, coming the same value. That's why, that is, if x y belongs to R2 and yx belongs to R2. Next slide is graphical represents of symmetric relation. A relation is symmetric if and only if every edge between distinct vertex in its diagram there is an edge in an opposite direction, so that BA is a relation whenever AB is a relation. There is a relation R1 equal to 1 1 1 2 1 3 2 2 2 and 3 1 on A. Set A equal to 1 2 3 is a symmetric relation because there is a vertex 1, there is also loop, and vertex 2 there is also loop, and vertex 1 goes to 2, another vertex 2 goes to 1, vertex 1 goes to 3, and vertex 3 also goes to 1. That's why it is a symmetric relation. Then another properties is transitive relation. A relation R on a set A is transitive if whenever AB belongs to R and BC belongs to R, then AC belongs to R. That is, ARB and BRC tends to ARC. This means if one element is related to second and second element is related to third, then the first is related to third. That is a transitive relation. That means, for example, R1 equal to 1 2 2 1 1 1 2 2 on set A equal to 1 2 is a transitive relation. Another example, another relation is R2 equal to 1 2 2 1 1 1 2 2 3 3 1 3 on A. A equal to 1 2 3 is a transitive relation. These are the examples. And the graphical representation of transitive relation. A relation is a transitive if and only if whenever there is a directed edge from a vertex A to a vertex B and from a vertex B to a vertex C. Then there also are directed edge from A to C. For example, R1 equal to 1 2 2 1 1 1 2 2 on A. 1 2 is a transitive relation. Showing in the graphical representation, there is a vertex 1. There is also loop. 1 goes to 1. Another vertex 2. There is also loop. And the 2 goes to 2. Then vertex 1 goes to 2. And another vertex 2 goes to 1. The relation, that means 1 2 2 1 1 2 2 1, that means 1 1 and 2 2, that is a transitive relation. Then we summarize these properties. Then reflective means AA belongs to A, that is ARA for all A belongs to A. Symmetric means AB belongs to R implies AB belongs to R, that is ARB implies BRA for all AB belongs to A, that is symmetric. And transitive means AB belongs to R and BC belongs to R. This implies AC belongs to R, that is ARB and BRC implies ARC for all ABC belongs to A, that is a transitive. Then next slide is determining whether the relation of the diagonal graph shown below is reflective, symmetric and transitive. In their graph, there is a 4 vertices, 1, 2, 3 and vertex 4. There is vertex 1, there is a loop. Vertex 2, there is also loop. Vertex 3, there is also loop. And vertex 4, there is also loop. Vertex 1 goes to vertex 2. Vertex 2 goes to vertex 3. Vertex 1 goes to vertex 3. And vertex 1 goes to vertex 4. Vertex 3 goes to vertex 4. And vertex 2 goes to vertex 4. In this figure, we can analyze this. There is a reflective relation. The relation is reflective since the diagram, the relation has loop at every vertex. That's why this figure is reflective. Another is symmetric. Symmetric means the relation is not in this figure. There is a no symmetric relation because the diagram of a relation has a directed edge from 2 to 3, but there is no directed edge from 3 to 2. This means there are the element 2 and 3 such that 2 are 3 and but not 3 are 2. That's why this figure is not a symmetric relation. Another is transitive. The relation is transitive. The diagram of the relation has the property whenever the directed edge from 1 to 2, then after 2 to vertex 2 to 3, there is also directed edge from 1 to 3. That's why the figure is shown is transitive relation. Then importance of relation. There are so much importance of relation such as shared theory, then foundation of shared theory. That means relation are one of the basis of concept of shared theory, which is fundamental on which modern mathematics was constructed. This help in understanding how element is differentiate, interact with and related to each other. Another importance of relation is modeling real world scenario. That means relation allow mathematical to model a real life scenario like social network whereby students are linked many different relationships, hence simplifying the analysis of complex system. Another is establishing function. Establishing function means the relations are essential in defining function, where are special kind of relation. Function are mapping from the element of one set to another such that every input corresponds with the must one input. That is the independent requirement of calculus and understanding. Then another important is understanding equivalence. Then relation group element into equivalence class, and this is key in much of mathematics, most of algebra and all of the topology. The relation of elements together marks different programs simply by throwing away apparent individual differences. Then another importance of relation is application of graph theory. Relation is graph theory are magnified as edge between bodies, such as repetition is fundamental in addressing problems related to convexity, path, and network. Finding this application in computer science and logistics. Another importance of relation is logical reasoning and proof. Relation also come into play within logical reasoning and within proof, where mathematics might establish link between different mathematical statements. This provides a basis by which mathematicians develop theorems and understand structure in mathematics. These are the importance of relation and application of reflexive, symmetric, and transitive. There are so many applications such as social network. Reflective in a social network also the reflection in friendship, that is a person A is friends with himself, then it is always true. Symmetric is identify it A is friends with B, then B is friends with A. Transitive in this sense can be stated as A is a friends with B and B is a friends with C, then A is also often considered a friends with C. Another application is the idea of equivalence class. That is to say, in the classification system like placing students in different grade, reflective ensure a student will be their own grade group. Symmetric creates for the fact that two students fall into the same grade, then they are interchanged the same, and transitive adds the deducing the fact that if the student A is the same grade as B and B is in the same grade in C, then A will also be in the same grade as C. Another application is database relationship. Then reflective in database term would mean the entire related to itself. Symmetry implies in case where is the recorded if linked to another record, then it is applied to other way around. Transitive helps to following relationship such that if A is related to B, B is related to C, then A is also related to C. Another is transportation network. The reflecting in the transportation system means any location is reachable from itself. Symmetric consider the route to be a bidirected, and if there is a route from A to B, then there is also route from B to A. Transitive is useful to finding indirect routes if A is connected to B and B is connected to C, then A is also connected to C. Another application is legal relationship. In a legal sense, reflective should say right concern oneself. It involves argument in which if one owe a duty to another, the reverse would be true, whereas transitive shows the context of legal observation. What if A owns a duty to B and B owns a duty to C? Then A. By transitive, may be seen as having same kind of duty to see indirectly. Another is recommendation system. It means the recommendation algorithms reflective would be that a user algorithm reflective would be a user and recommended is similar his and her own performance. Symmetric is when two users with similar tasks recommendation to each other favorite item. Then next slide is conclusion. Then first point is reflective ensure that in every set every element is related to itself, while the former property is basic in relation. And another symmetry is that existence of mutual relationship between elements. This is significant in social network and equivalence relationship. Transitive enables the induction of relationship between elements, thus adding logical reasoning through a process of connectivity of different systems. The understanding of such property in imperative in mathematics and computer science, including in real domains like database and social network. Graphical represent is provide a clear visual understanding how these properties mean test in the relation. It enhances the mastery of concept to analyze and solve problem in the many fields. These are the conclusion, and I make the presentation from the reference of these are the references, and thank you so much.